Here we're going to look at question 19 from the BMAT 2019 paper. So in this question, they begin by giving us some information. We're told that originally the universe was full of electromagnetic radiation in the form of intense gamma rays. It's also been deduced that the universe has been expanding since this time, and one effect of this is that this gamma radiation has now become microwaves, or is in the microwave range of the spectrum. The question then goes ahead and asks us which of the following statements is/are correct, bearing in mind that the answer might be none of them. And then it gives us these three statements, which is that expansion has caused an increase in the frequency of the radiation, that expansion has caused a decrease in the wavelength of the radiation, and that the expansion has caused frequency to change in direct proportion to wavelength. So if you'd like to have a go answering this question yourself, then please just pause the video now and have a go. Otherwise, we'll try and do it together in a moment. So to answer this question, then we can go ahead and just move our information onto the next page. We're going to just keep the question and we're going to summarize this information here. So here's just the question, here are our statements, and here I've just summarized that we had gamma radiation initially, and then the expansion of the universe has resulted in us having microwave radiation now. So we can move on to trying to think about which of our statements are going to be correct or incorrect. And reading the first one, which is that expansion has caused an increase in the frequency of the radiation, we see that we need to try and think about the frequency of our gamma and microwave radiation. Looking at our second one, we see that we're considering wavelength of the radiation, and finally we're thinking about how the frequency has changed in proportion to wavelength. So we need to try and think about frequency and wavelength of our radiation. To do this, it's probably best to try and draw up a table of what we know about gamma and microwave radiation. So what I'm going to do is put this little table here where we're talking about the energy, frequency and wavelength. Now while we're not talking about energy here, I think it's quite useful to put the energy up because it might help us think about the frequency and wavelength. And it's something which at least people might remember, so it might kind of spurt on some answers to frequency and wavelength related answers of these. So, which of gamma and microwave radiation is going to have a higher energy? Well, we know this is just going to be gamma radiation. Gamma radiation is kind of the highest energy electromagnetic radiation that we get, and microwave is much more towards the kind of lower end of radiation, or radiation energy, if you like. Then, moving on, we can think about the frequency. And frequency is just proportional to energy, so they both move in the same sort of way, which means that because gamma has higher energy and microwave has lower energy, then the frequencies are going to go the same way. Gamma has a higher frequency and microwave has a lower frequency. Now this is going to be inversely proportional to wavelength, just generally speaking. This is just some general relation which we always use whenever we're talking about any kind of radiation. The frequency is inversely proportional to wavelength. So that means that the changes here are going to be the opposite way. That wavelength is going to have, or gamma is going to have a lower wavelength, and microwave is going to have a higher wavelength. Now with all this information, we can go ahead and try to go back to our statements and think about which are going to be correct and which are going to be false. Looking at our first statement, that the expansion has caused an increase in the frequency of the radiation. We've gone from gamma to microwave radiation, so the frequency has gone from some higher frequency to a lower frequency. So no, this is going to be false. The inverse of what it says is true. Statement 2 says the expansion has caused a decrease in the wavelength of the radiation, or we've gone from gamma to microwave, so the wavelength has gone from a lower wavelength to a higher wavelength. So again, this statement is also going to be false. The final statement says that the expansion has caused frequency to change in direct proportion to wavelength. Now, this goes against what we've written here. This is a general expression which is always going to be true. It can't kind of change otherwise, really. It has to be true for waves. So this expression doesn't really make sense. It goes against the definitions of frequency and wavelength, so it also has to be false. Therefore, as we can see, all three statements are false, and this is going to correspond to answer A, which we're given in the question.